1.7 continued is going to be about quadratic inequalities. So we can tell a quadratic inequality from a linear inequality because it's going to have a degree of 2. So it's going to be squared like this one is. The way that we are going to solve a quadratic inequality is we're going to replace the inequality with an equal sign and then solve by factoring or quadratic formula. Then we are going to set up a test chart and label the intervals on the test chart using interval notation. And then we'll test a value from each interval. And then we're just going to exclude any section that comes out false. So here's our first example. We just start by thinking of this like an equal sign. And then this will factor nicely. It would be x minus 4 times x plus 3. Remember, you can do box factoring to get that answer. Then to solve for our critical values, we're going to set each of these parentheses equal to 0 so that we get x equals 4 and x equals negative 3. Those numbers are going to be what we call our critical values. I'm just going to put them on a number line. It's important that they go in order from left to right, but they don't need to be like equally spaced. Like they don't need to be accurate in that manner. I just need to have negative 3 on the left and 4 on the right. Since this was a less than, I am going to put an open circle on the negative 3 and an open circle on the 4. And then I usually draw dashed lines to separate the sections. So now I've got my number line into 3 sections. The intervals that go with each section, just imagine that I had this shaded. Left to right would be negative infinity on the left and negative 3 on the right with an open circle, so that will be a parenthesis. So this little interval will be negative infinity to negative 3. This interval here will go from negative 3 to 4. Since it's open circles on both ends, they will be parentheses. And then this interval, left to right, starts at 4, ends at infinity. So the solution to this inequality is going to be some combination of these intervals. What we need to do is pick a number between negative infinity and negative 3. It's your choice on what you choose. I'm just going to pick, I don't know, negative 10. So I'm going to test negative 10, which means I'm going to replace all of my x's with negative 10s. So I've got negative 10 squared minus negative 10 minus 12. When I work through that, that's 100 plus 10 minus 12, which comes out to be like 98. So the question is this less than 0? 98 is not less than 0, so this is false. So I'm going to exclude this section. It's not going to be a part of the solution to that inequality. Then I get to test a number between negative 3 and 4. If 0 is in my interval, I almost always test it. I can test any number as long as it's not negative 3 and it's not 4. It just has to be somewhere in between negative 3 and 4. 0 is a good one. So I'm doing 0 squared, which is 0, minus 0, which is 0, minus 12. So I get negative 12 is less than 0. That is true. So what I usually do is up above, I will shade that section. And then I have to test a number between 4 and infinity. You can pick anything you want. I'll just pick 5. So I'm going to do 5 squared minus 5 minus 12, which is 25 minus 5 minus 12. So 20 minus 12 is 8. And I want to know, is 8 less than 0? It is not, so that is false. So I'm going to cross that out. And then the interval that I'm looking for my answer is negative 3 to 4. So that is the solution to that inequality, negative 3 to 4. I have a few more examples for us here. 2x squared plus 5x is minus 12 is greater than or equal to 0. So I'm going to start by replacing the inequality with an equal sign. 2x squared plus 5x minus 12 equals 0. I am going to either factor that or use quadratic formula. I'm going to box factor it. I'm actually going to have to write this one out because I'm not sure how it factors. I need what multiplies to negative 24x squared but adds to 5x. So that's going to be 8x, negative 3x. So I got a 2x there, x there, negative 3, 4. So it factors to x plus 4 times 2x minus 3. So I set x plus 4 equal to 0, which gives me x equals negative 4. I set 2x minus 3 equal to 0. So I get x equals 3 halves. Those are the two values I'm going to put on my number line. Remember, I have to go in order, so I'm going to put negative 4 on the left and 3 halves on the right. Since I had greater than or equal to, I'm going to be using closed circles for both of those, which usually means I will draw solid boundaries. And then for my intervals, left to right, this interval starts at negative infinity, ends at negative 4 with a bracket. This interval starts at negative 4, ends at 3 halves, and has a bracket on both ends because they're closed circles. This interval starts at 3 halves, ends at infinity, bracket for the closed circle, parenthesis for infinity always. Then we're just going to test values in my original inequality. So I might pick negative, it doesn't matter as long as it's between negative infinity and negative 4. Negative 5. So I'm going to do 2 times negative 5 squared plus 5 times negative 5 minus 12. That is, negative 5 squared is positive 25. 25 times 2 is 50. And then positive 5 times negative 5 is minus 25. And then minus 12. So that's 50 minus 25 is 25. 25 minus 12 is 13. And is 13 greater than or equal to 0? Yes, it is. So I'm going to shade that part of my number line and move to the next section. What's a good number between negative 4 and positive 3 halves? How about 0? If I put 0 in for x, I do 2 times 0 squared is 0, plus 5 times 0, which is 0, minus 12 is greater than or equal to 0. So basically, is negative 12 greater than or equal to 0? It is not. It is less than 0. So that is false. X that out. And move on. A number bigger than 3 halves but smaller than infinity. How about, I don't know, I'll just do 10. It doesn't matter what number you pick. 2 times 10 squared plus 5 times 10 minus 12 is greater than or equal to 0. Well, 10 squared is 100, times 2 is 200, plus 50 minus 12 greater than or equal to 0. Yeah, 250 minus 12 is greater than 0, so this is true, which makes this interval also part of the solution to the inequality. Now, we have not seen an interval that does this yet, where we have an interval over here, and then we skip a section, and then we have another interval here. Using interval notation, what we're going to do for that is we're going to list the first interval, so negative infinity to negative 4, and then we use the union symbol to show that we have a gap in our graph. So negative infinity to negative 4, union, and then we put our second interval, 3 halves to infinity. And that is how you would put your answer. All right, we got a couple extra examples. So if if you don't need extra examples, maybe you could just skip ahead and not watch these. I'm going to start by replacing the inequality with an equal sign. X squared minus 2x equals 15. In order to be able to factor that, I'm going to need to get it equal to 0. So I have x squared minus 2x minus 15 equals 0. When I factor it, that is x minus 5 times x plus 3. So I will set each parenthesis equal to 0. Which gives me two critical values. X equals 5 is one of them. X equals negative 3 is the other. So I'll put those on my number line. I got to go in order. So the negative 3 will be to the left and 5 will be to the right. Since my original inequality was less than or equal to, I'll use closed circles when I start my tests. And then the intervals, this left interval starts at negative infinity and goes to negative 3. Negative infinity always has a parenthesis. Since negative 3 has a closed circle, that will be a bracket. The second section starts at negative 3 and ends at 5. Since there's a closed circle, I'll use a bracket, and another closed circle, I'll use a bracket. And then my third section starts at 5 and goes to infinity. So I'll use a bracket at 5 because of the closed circle, but infinity always gets a parenthesis. Then we've got to pick a number to test in this original inequality. So something between negative infinity and negative 3, like maybe negative 5. I'm going to do negative 5 squared minus 2 times negative 5, and I need to see if that is less than or equal to 15. Negative 5 squared is 25. Negative 2 times negative 5 is positive 10. So is 25 plus 10 less than or equal to 15? No, it is not. Cross it out. Between negative 3 and 5, 0 is a good number. So if I put in 0, 0 squared is 0, 2 times 0 is 0, and I need to see if 0 minus 0 is less than or equal to 15. It is. So this section of the number line is a part of my solution. And then 5 to infinity, maybe x is 8. So I'm going to do 8 squared minus 2 times 8. Is that less than or equal to 15? 8 squared is 64. Minus 16. Is that smaller than 15? 64 minus 16 is like, what, 30 something? I don't know. 48. It's 48. Is 48 less than or equal to 15? No. So cross out that section. So the only part that is the solution is that center section from negative 3 to 5 with both being in brackets. Okay. 3x squared is greater than 11x plus 4. So I will start by replacing that inequality with an equal sign. So 3x squared equals 11x plus 4. In order to factor, I need everything on the same side. It's got to be equal to 0. So I'll have 3x squared minus 11x minus 4 equals 0. Let's box factor that. What multiplies to negative 12x squared but adds to negative 11? would be negative 12x and plus 1x. So I got 3x and x and negative 4 and 1. So that's going to factor to x minus 4 times 3x plus 1. Set each parenthesis equal to 0. So x minus 4 equals 0 gives me a critical value at x equals 4. Setting 3x plus 1 equal to 0, I need to subtract the 1 over. So I get 3x equals negative 1. Divide by 3. And that other critical value is x equals negative 1/3. So on my number line, I'm going to put two critical values. One at negative 1/3, the other at 4. The original inequality was greater than. So I'm going to use open circles at negative 1/3 and at 4. And then put my intervals. This section on the left end is negative infinity. On the right end is negative 1/3. Because of the open circle, that has a parenthesis. The middle section starts at negative 1/3, ends at 4. Both are open, so parentheses. And then this section starts at 4, ends at infinity, open circle at 4, and infinity always has a parenthesis. So there are my sections. And then I have to pick test values. So something between negative infinity and negative 1/3. I could choose anything, like negative 1 is in there. So I'm going to do 3 times negative 1 squared. And I'm checking to see if that's greater than 11 times negative 1 plus 4. Negative 1 squared is 1 times 3 is 3. So is 3 greater than negative 11 plus 4? Negative 11 plus 4 is negative 7. So yes, 3 is bigger than negative 7. So this section gets shaded, and this interval is part of my solution. Then I'm going to pick a value between negative 1/3 and positive 4. I like to pick 0. So if x is 0, then the left side, 3 times x squared would be 0. And the right side would be 11 times x, 11 times 0, which is 0, plus 4. So that says 0 is greater than 4. That is false. So this section is no good. And then pick a number bigger than 4, like 5 or 10 or 20 or 100. It doesn't matter. Pick your favorite number. 10 is an easy one because when I do 10 squared, I get 100. So 3 times 10 squared gives me 300. 100 squared is, or 10 squared is 100 times 3 is 300. Is that greater than 11 times 10 plus 4? 11 times 10 is 110. And 110 plus 4 is 114. So yes, 300 is bigger than that. So this section is a part of my solution on the number line. And then the interval that I wrote is a part of the answer as well. So the solution to this inequality includes two intervals. The first interval goes negative infinity to negative 1/3. And then I skip over some numbers, so I use a u. And then I start back up with 4 to infinity. So this would be the solution to that inequality. Let's do one story problem here about projectile height. If a projectile is launched from ground level with an initial velocity of 96 feet per second, its height s in feet, so s is in feet, that's this, t seconds after launching is given by the following equation. So s is the height, t is how long the projectile has been in the air. When will the projectile be greater than 80 feet above ground level? So my height is given by negative 16 t squared plus 96. So they're asking me basically, when is the height going to be greater than 80? So when is the height greater than 80? So I'm going to be using this little guy in place of height. So I'm really solving negative 16t squared plus 96t is greater than 80. Okay, to solve this quadratic inequality, what I'm going to do is replace the inequality with an equal sign and then solve the equation. I'm probably going to factor this. Usually these work out really nicely. If I move everything to the left side, I see that I have a negative out in front, so I will usually factor out a negative GCF. A lot of times all of these numbers are divisible by 16, so let's check it. Does 96 divide by 16? Yes. Does 80 divide by 16? Also yes. So I'm going to factor out negative 16 as the GCF, which is going to leave me a positive t squared minus 6t and then plus 5 equals 0. So when I factor that, that's going to give me t minus 5 times t minus 1. The zero product property says that I should now set each part that has a variable equal to 0. So this negative 16 with that was the GCF, we ignore it because there's no variable. So we don't have to pay attention to the negative 16. We just set t minus 5 equal to 0 to get t equals 5. We set t minus 1 equal to 0 to get t equals 1. Those are our two critical values that are going to go on the number line. So on my number line, I have to put 1 and 5. Since my original inequality was a greater than, I will be using open circles on the 1 and 5. And then my intervals, that left section starts at negative infinity, goes to 1. Infinities always have parentheses. Since that's an open circle, it also has a parenthesis. Then I go from 1 to 5. Also, both have parentheses because of the open circles. And then this section has an open parenthesis at 5 and then goes to infinity. Then we got to test intervals in this original inequality, or test values. So between negative infinity and 1, I'm going to pick 0. So that's going to give me negative 16 times 0, which is 0, plus 96 times 0, which is 0. Is that greater than 80? No. What about a number between 1 and 5? Like maybe 2. Negative 16 times 2 squared. So negative 16 times 2 squared plus 96 times 2. Is that greater than 80? 2 squared is 4 times negative 16 is negative 64 plus 96 times 2 is 192. Is that bigger than 80? Yes, negative 64 plus 192 would be bigger than 80. So this is true. So this little section is part of our solution. And then if I pick a number bigger than 5, I'm going to go with 10 again. I have negative 16 times 10 squared plus 96 times 10. Is that bigger than 80? 10 squared is 100. Times 16 is negative 1600. Plus 96 times 10 is 960. Negative 1600 plus 960 is like negative 600 something, and that's not bigger than 80, so that is false. So neither of these two sections were part of the solution to this inequality. The only one that is -1 to 5, which means that the projectile is going to be greater than 80 feet above ground level between 1 and 5 seconds. Now that should make sense based on what we know about projectiles. So when I launch a projectile from the ground, let's say here's the ground, that projectile launches from the ground, it goes up, it goes back down. So it should make sense that if I'm looking at something like 80 feet above ground level, it should happen 2 times. One time on the way up and then one time on the way back down to the ground.